Okay, 2.6, we're going to talk about graphing inequalities. Okay, we've done graphing lines. We did that a couple sections ago. So this section is exactly like graphing lines with two exceptions. You have to do two more things after you graph the line. One is you have to determine whether the line is solid or dashed. The second thing you have to do is shade. An inequality always has a shade because it's all values less than or greater than the line. So it's not just one point that's equal to the answer. It's a whole range of points. So you have to shade which range the answer is. Okay? So if I have the inequality y is less than 3x plus 1, the first step in graphing these is treat it like an equation. If I were going to graph the line y equals 3x plus 1, how would I do it? Where would I start? How do you graph a line in slope-intercept form?
Do you do the slope?
Well, you're going to use the slope, but you always start at a certain point. What is that point? In this case, it's 1, the y-intercept. Okay? Because 1 is right here. Now I'm going to use the slope. The slope is, remember, 3 over 1. I'm going to go up 3 over 1, and there's my second point. Okay? So if this were all I needed to graph, the equation, I would just connect the points, right? But now I need, because it's an inequality, I have to think about those two other things. Okay? So if the inequality does not have an or equal sign, it's open, your line will be dashed. Say that again. If the inequality does not have an or equal to, okay, your line will be dashed. If it has that bar that means or equal to, it will be solid. So in this case, it's less than, it's not less than or equal to. So when I connect these points to make my line here, it's got to be dashed. Okay? So I've just completed the first add-on for inequalities that I have to do for adding on to what I have to do to graph lines. The second one is shading. Okay? If your graph, if you have a quiz or a test, and you were asked to graph an inequality and you do not have shading, you've missed the problem. Because you must know you have to have shading on an inequality graph. Okay? The easiest way to figure out where to shade is to use something called a test point. And the easiest test point there is the point 0, 0. Okay? The only time that point won't work is if the line itself goes through the point, because that won't tell you anything. Okay? So you'll have to find a different test point, like 1, 1. You can pick any test point there is. You can pick 1,376, 2 million, whatever, but make it easy on yourself. Just choose 0, 0. Okay? This line does not go through the origin. So I can use 0, 0 as a test point. And when I say use it as a test point, all we're going to do is we're going to plug in 0 for y, 0 for x, which just drops the 3x altogether, right? And we have 1. Now we're going to ask ourselves, is this true? Is 0 less than 1? Yes. Okay? Because 0 is less than 1, the point 0, 0 is included in the shading. Okay? So when I go to shade, I'm going to shade this side of the line. Because 0, 0 is one solution out of infinite number. But 0, 0 is a solution to the shading. So that's the side I shade on. Want me to do another one? Because this is done. I've done this one. So let's do one more. Y is greater than or equal to 3x plus 7. Where do I start? 1, 2, 3, 4, 5, 6, 7. The y-intercept. And then I use the slope. 1, 2, 3 over 1. Now I've got to decide, is it going to be solid or dashed?
Solid.
Solid, because I have an or equal to. Does this line, badly drawn, actually go through 0, 0? No, so I can use 0, 0 as a test point. So I'm going to plug in 0, 0. Is 0 greater than or equal to 7? No. So 0, 0 is not a solution, which means I'm going to shade everything on the other side. Following?
Yeah.
Okay. In the textbook, it talks about it's helpful to get your equation into slope-intercept form. Okay. You can really graph it either way. I mean, if I had an equation in standard form, how do I graph this in standard form? What's the fastest way? Yeah, to find your x and y intercepts, right? Just the cover-up method. Cover up x to find my y-intercept. That's 3. Cover up y to find my x-intercept. That's 2. I've got, let's make this, sorry. I've got a line now, 2 points, right? But before I connect them, I want you to always think, is it going to be solid or dashed? In this case, it'll be dashed. Okay, and now I have to shade. So if I plug in a test point, 0, 0, does it go through that origin? No, so I can use 0, 0. 0 plus 0 is 0. Huh. I guess we're going to do that. Is 0 less than 6? Yes. So that means 0, 0 is included. So it's going to be this side that's shaded. Make sense? It's really not hard. You just have to remember 2 more things. Graph the line like you know how to graph now, but remember whether you make it dashed or solid and where to shade. Good?
So if it is equal, if 0 is included, you're going to shade the bottom half right now, right?
Yes, that's what I did. Okay, so let's look at the textbook check. The inequality below will be graphed using what kind of line, solid or dashed? Dashed, good. What's the easiest point to use when testing where to shade an inequality graph? 0, 0. Other than dashed or solid lines and shading, an inequality is graphed exactly as a line would be. True. It's easiest to graph an inequality when it's in standard form. False. The book really really said put it in slope-intercept. You can graph it either way, whatever you're comfortable with. In the video on graphing inequalities, I added a lengthy comment at the end. What did the comment refer to? What's that?
No, what you for the test point?
Who watched the video? Do you know, and you remember?
I skipped through it.
Skip through it. Okay, we're going to go look at it, because that's what I like to do. I hate to have my talents wasted.
So is there question marks in there?
I don't think that's the one.
What was the last video?
Probably this one. I always try and plug in 0, 0 for my test point unless 0, 0 is on the line. In that case, pick an easy point like 1, 1. When you plug in 0, 0, you just need to ask yourself if the inequality is true. If so, the side of the line that includes 0, 0 is shaded. If not, the side of the line that does not include 0, 0 is shaded. So in the problem, and you don't see the problem, if you had plugged in 0, 0, you would have 0 probably is less than 5. This is true. Therefore, the side of the line that includes 0, 0 is shaded. So that was the point on that one, that 0, 0 is what I used as the test point. Okay, you guys make sure I spent a whole summer putting all of this coursework together, and it wasn't because I just wanted to spend my summer. It was so that you guys had resources available to you to learn the material. So if you're not reading the textbook and watching the videos and you're wondering why you don't understand something, that's why, because you're not using your resources. You're just expecting me to, in 10 minutes, to teach you everything you need to know, and it's not possible. So if we don't start doing that, I can spend the whole period teaching you what you need to know, and then you can do the homework on your own. But the purpose of flipping is so you guys take initiative and come to to the class ready, having watched the videos and read things like this, so that when I just do a 10-minute review, it's actually helping you put together what you've already learned, and we're just making you more proficient in it. And then we can spend the rest of the time with you actually working on your homework with my help. I think that's more effective, but it's only effective if you do the work. Okay? If you're watching the video and you just fast forward through it thinking that you're going to get everything you need, doing that, you're not. Okay, I appreciate that you actually watched the video, but the point is, all of this has a design. And if you guys aren't following the design, then we're going to have to switch it up and go back to a traditional method where I just spend the whole period lecturing, and you go home and figure things out on your own. I don't think that's what you want. But if you don't do the pre-work, that's the only thing I can do, because otherwise you're not learning it. Okay. Any more 2-5 questions? Okay.
So it's like the same one that we did last time. X squared plus 4x minus 4.
X squared plus 4x minus 4.
And then f equals x plus a minus f a.
F of
F of x plus a. And minus f of a. When I did it, it said that f is not defined in this one.
Oh yeah, you wouldn't have f in your answer, because you're going to put x plus a everywhere there's an x, and then you're going to subtract this whole thing and put an a. So you'll say x plus a squared plus 4 times x plus a minus 4. Then you're going to subtract a squared plus 4a minus 4. And then you have to simplify that whole thing. And where most students miss this problem in their simplifying is forgetting to distribute the negative to all 3 terms. Okay, so this one should be how you had it simplified for your first answer, because that's what you did for the first answer, was x plus a, right? Did you have to do f of a for your second?
Well, so it's just those two.
Well, so there's 3 parts to this problem, right? The first part was plugging x plus a in. What was the second part? Okay, so what I'm saying is your first answer was this. Your second answer was this. You're subtracting those 2 now and simplifying.
Oh, so we can do it.
Mm-hmm.